Hello, in this video we need to talk about state space representation of control systems. For example, if we have this equation here, it's y triple dot plus 5 two dots like this one here, plus 2y dot plus 6y equals 4u double dot plus 2u dot minus 3u. This means the third derivative of y, and this the second derivative of y, and so on. This second derivative of u, and this the first derivative of u with respect to time. So this is a differential equation of a continuous system. Okay, the procedure or the method we need to use here, we replace these two variables in our equation by another variable, let's say z. Okay, so let's take this example. Okay, so this is our example here. We replace the two variables here. We have the first variable is y and u. We replace these two variables by another variable which is z, for example. Okay, so we take the left hand side here. So we replace y by z, this first one. So we take z triple dot like this one plus 5 z do dot plus 2 z dot plus 6z will equal to here just make 2. Okay, and so on. We need to use this the right hand side. It's it's y equal to 4z double dot plus 2z dot plus minus 3z. Okay, so this is the first thing. We replace y and u in this manner. Take y replaced by z like this one, and equal to only the variable in the right hand side, and you take the whole right hand side here and replaced by z and equal to the variable which is in the left hand side. Okay, now let b, because we have here third derivative, so we will make define three variable which is x1 equal to z, x2 will equal to x1 dot equal to z dot. Okay, and x3 will equal to x2 dot and equal to x1 double dot and equal to z2 dot. Okay, so what we have else here, so we have that's what we need. X1 dot from here to equal x2, and x2 dot will equal to from here to equal to x3, and x3 dot from this one to equal to z triple dot. Okay, will equal to z triple dot, and where we get this z triple dot from this equation. So we take this and this and this to the right hand side, so it will equal to u minus 5 z double dot, and z double dot will equal to x3. So 5 x3 minus 2 z dot will equal to x2. Okay, and minus 6z, and z we defined as x1. Okay, so we left we get this three nice equation. Okay, here all these three. Okay, these three equations. From the first equation we get these three equations, and the second equation this lead to y will equal to 4 z double dot from here will equal to x3, okay, plus 2 z dot x2 minus 3 z, so it will be minus 3, and z we defined as x1. Okay, so we get these four equations, and we are ready to form the state space form for this problem. Okay, so state space we have the state space form which is equal to ax plus bu and y is equal to cx plus du. This is the form of state space. Okay, so here we have three-dimensional system. x1 dot x2 dot x3 dot, it will equal to some matrix 3 by 3 matrix, and this is our states x3 plus some column vector here, because we have only one input, it's just u. If you can review your differential equation here, you have the forcing input only one variable, which is u, and it has its derivative, okay, but it's only one variable. Okay, so times u. So to equal here from this equation to equal x1 dot equal to just x2. So here 0, and we have here 0 and 1 and 0. So this multiplied by this 0, so 1 x2 and 0 times this one. Okay, x2 dot from this equal only x3, so 0 0 1, and this equal to 0, and the final one x3 dot will equal to u. So here we have 1 minus 5 x3, so this 5 minus 5, and minus 2 x2 minus 2 sorry, and minus 6 x1. Okay, so this is our state matrix. Okay, dynamics, I mean this is the dynamic of the system. You can find here, and you can know the stability of the system from this equation, from A matrix, I mean. Because if you see the eigenvalue and check the eigenvalue, if it is in the left hand side, if we are talking about a continuous system, if it is in the left hand side, the root, so the system is stable. If it is in the right hand side, so your system is not stable. Okay, this is strictly speaking. And now y will equal to, from this equation, minus 3 times x1 and 2 times x2 and 4 times x3. So x1, x2 and x3. So this is, there is no D matrix here, so it is 0. There's no need to write it. So this is our differential. So this is our state space equation from this differential equation. Okay, I hope the answer is very clear and simple technique. Just to review it, you need just to replace these two variables y and u by another variable which is z, like this one. You take the same one and replace by z equal to what is the variable here in the right hand side, which is u, and you take the right hand side and replace by z and equal what's in the left hand side, y, like this one. And from this you define how many states we have, how many derivatives you have here, the highest order here, which is 3. So we have 3 variables, and you find these 4 equation, and you make your state equation and the output equation here, and that's all for this representation. I hope this video is very clear for you and clarify many things to you, and see you next time. Bye bye. If you have any comments, if you have any question regarding this field, please leave it in the comments below. Thank you for watching.